Start our next topic, which is topic 7, which is on data management. In my normal, just call it data management. In the semester version of this class, where you're working at more of a traditional pace, this is the topic that I introduce right during the midterm exam. So usually this topic is introduced the day before the exam because it is a very straightforward topic and we're just practicing using loops and functions at this point. The purpose of it is it allows us now to communicate with MATLAB data without just having the data stored in an array in an M file. So this is typically how you would always get data into MATLAB. So anytime that I've given you a data table that you've had to then copy into MATLAB as an array by hand, or up to this point I've had you just go on and copy and paste lines of code from M files, that is something that you'll basically never do when you're actually using MATLAB. What you'll actually need to do is be able to import data in from other formats. So that's what we're going to learn about today. And when I say it's straightforward, I mean that there's not as much like algorithm development and problem solving needed in order to do this topic. You're going to be doing new algorithms in this lab that we've never done before. You get to write a binning algorithm. But for the most part, you just need to understand the syntax and the difference between the different formats, which gets people every time still, but again, it's just a syntax thing. So basically MATLAB can import and export data in more or less any format. So there's certain engineering software that we use that formats its data in a particular way that's very customizable. For example, some of the modeling software like ANSYS or some of the Fluent packages, SolidWorks, for example. All of those software programs have files that are contained in a particular way. So the software is choosing where it's placing different pieces of information. And so some of those more specialized software packages have their own usually just searchable MATLAB import-export commands. So you just have to find them, or someone else has already developed them. However, there's a bunch of standard formats that almost everyone uses that are already available in MATLAB, and so we're only focusing on those. But I help students after they take my class constantly, and the number one thing that students have me help them with is how to import data into MATLAB, because they have data in some other format they've never used before and they're not able to interpret how to get it into MATLAB. And it's also the first thing that I had to do with MATLAB when I ever used it. And when I was in school, we didn't have a class on MATLAB. If you were using it, you just figured it out on your own. Googled, looked at forums, because at that time, universities were still teaching their engineering students how to program in Java, primarily. So there's two types that we're going to focus on, just because we have to pick some, so I picked the two most common. The first one is the native format. So the native format has an extension, .mat, so you've probably seen it before. Some people accidentally save their M file as a .mat extension, but a .mat extension is a data file extension, so it's not an executable file like an M file. It doesn't do anything, it just is a way to store data. So it's basically equivalent to a text file. That's the way you can think of it. Let's see. So a couple things I wanted to show you with the native format. The import command for the native format is load. So if you have a file name that goes as an input to the load command as a character string, and it's just the verbatim name of the file, or if the file is not in the folder, it needs to include a path to the file. So load is what you use to bring data into your workspace so that MATLAB can use it. Or if you're using a function, it just gets brought into that function space. And the thing that's important about this native format is that MATLAB created the format, and so it works really well with it. So for example, any of the data that you are loading in comes in with variable names. So it being native to MATLAB means that MATLAB saved this data, and when MATLAB saved it, it kept the variable names attached to it. So if you just had a bunch of variables saved to your workspace and you saved them to a .mat file and then you loaded them back in later, it would just come back all as it was originally written. So that's what's really nice about it. It's used all the time to get around having to rerun a really long code. So let's say you wrote a code, takes 2 days to run, not weird, very typical, and it creates all of these calculations. Instead of having to rerun those calculations to go and post-process them or do something, you can just save them to a .mat file and then load all those calculations back in rather than rerunning the file. And it saves a lot of time. So the export syntax for the native .mat file is save. So I'll show you both of these in MATLAB and just point out a few important features about it. I find at this point people start to get very confused about the two different file types now. So just keep in mind that the .mat file is just a data file. Its only purpose is to store data. It's not executable. Where the .m file can't store data, it can only save commands. So in MATLAB it's called a script file, but actually MATLAB has gotten into the habit of just saying it's an M file. But in other programming languages this is called an executable file or a script file. And its purpose is just to save the lines of code that run the commands. And there are a couple different variations of this syntax, which I'll show you in MATLAB as well. So let's just talk about non-native formats. So the most common that I find that engineering students use after this class are text files. That's probably the most common. A lot of instrumentation writes its data into text files for some reason, because they are by far the most annoying thing to read in, because they all have different delimiters like spaces or commas or colons. They also have different headers, and MATLAB actually is not very good at generalizing the algorithm to read in text files, so they have like 7 different import-export commands for text files, and you more or less just have to guess and try each of them until you find one works.
So what is that?
A delimiter separates pieces of data.
So like
Yeah, so it could be a tab, a space, a comma, a colon, and so if you've ever read data into Excel, you've probably seen that you have to choose that, but Excel is actually better at it than MATLAB for the most part. Mostly because it's more visual, so you actually get to see the file when you read it into Excel, where MATLAB you don't see it, so you have to just keep guessing until it works. Most software, particularly software that isn't as user-friendly Is this on autofocus or no? When I say user-friendly is you have to have more training to use the software, which is typically what a lot of engineers end up doing once they get trained for a particular position. A lot of those softwares will have files that are binary files, which means they're not human readable, which means you can't even open them to see what's in them. Some other software has to open them for you. So MATLAB is very good at this, but you have to really know how to use it, and we're not going to cover that at all. But if you ever get further into research or computing or modeling, this is kind of the direction that you'll need to go there. And then the other one that's very common is Excel files. So I think those I would summarize as the three most common non-native formats that engineers are using at various stages. And Excel and MATLAB pair really well together now. It's gotten to the point where MATLAB has a very smart algorithm, so you actually have to understand very little and able to use it. So I want to show you. Oh man, I didn't know these were all open. Okay. I'm going to show you, so we're only going to do map files and Excel files. That's what we're going to focus on in this class. But I wanted to show you how you can find this. It's just in the help. But I just like to show this shortcut to it. If you just search, this is so loud today, MATLAB supported file formats, and go to the help page for that. There is just this table that summarizes all of the different file formats and their import-export commands. And this is just what you have to do every time, is you have to look at what kind of file you're trying to read in, and then find the command for it, and then you'll probably need to go into that function and read more about it to understand what kind of inputs it needs and stuff like that. But just to give you a general idea, so here's all of the text commands. Here's the spreadsheet command. I see people using read table and write table for Excel, which is also an option. But I don't prefer it. I like the XLS read, XLS write commands. So that's how the labs are written. And then here you can just see all these other file formats, images, audio, video, anything you can imagine. So this is kind of what you have to get used to, is just going into this table in the help. All right, so what we're going to do is just focus on Excel, and then XLS read, XLS write are the two commands we're going to use. I'm going to show you some things in MATLAB right now with this, but I want to make this point very clear right now, is that when you're using the load command for map files, the variables come with the data. When you're using the XLS read command or any other non-native format, you have to give it a variable to put all the data into. If you just type XLS read and read in the data, it reads it in and it prints it to the screen. That's all it does. It doesn't save it. So just like defining variables, it's the same thing. You need to give the data a variable to go to. And you don't do that with load. So I see people will write like data equals load. That doesn't work. It doesn't need that. And it doesn't do anything either. I don't think it provides an error anymore, but it doesn't do anything. All right, so let's go into MATLAB. I have a data file here that I want to show you. how to read in, and then I'm going to show you some of the read-write functionality. Okay, so let's start by just typing in or reading in the file. So I have this file right here, global population data. I don't know if we're using that this semester, but this all works the same with the autofill. So if you just start typing the file name or the function name and then using the tab, it'll autofill it in. So let's start by just... Yes, it has to be in your folder. So if I just move this into one of these other folders, and then I try to read it in, it's not going to be able to find it. That's not the way that all computers work, though. Some of them will search within folders that are in that folder, but in general, you should do direct paths. So, for example, I put that in print, so I can just do a direct path to the folder where it is, and then it will work. Or I've now put it in this folder again, so I can read it that way. But what you'll notice is anything that I'm doing here, that there's nothing that's going into the workspace other than the default ANS variable, but as soon as I do something else, that's gone too, right? So the data is not saved, it's just read. MATLAB's just reading it for you. So if you want to, if you need to access the data, which you always do, otherwise why would you read it, you need to save it to a variable name. Because we've already spent so much effort on understanding arrays, what we typically do is we save all of the data, even though we can look at this. This data is across multiple columns, it has multiple rows. But because we understand how arrays work, we can see that all of the data is stored within the same orientation that the Excel spreadsheet is. So there's like 100 rows and 4 columns. And so if we want to access particular parts of this data, like if we want to access just the years, we can just go through and access the first column, which is just the first years. However, you can also just originally read in particular columns. So for your lab that you're going to be working on, I've given you a spreadsheet that has like 500 columns and like 4,000 rows. So I did that because it forces you to have to be smart about how you're reading and writing data, because that's very typical of what you're dealing with. So if you just try to read in all the data like I just did, it's very slow. It takes like 30 seconds to a minute depending on your computer to read in the data file. So you want to do a couple things to get around that. This actually does not speed up the code. What I'm going to show you, it still takes just about as long, but it helps with memory because you're not reading in all that data. So what you do is instead of reading in the whole sheet, the whole sheet, you can just read in one column. One thing that's different on different operating systems is the XLS read and write functionality. It very much depends on your operating system. You also have to have Excel because it communicates with Excel to do all this read-write. So if you don't have Excel, then on your personal computer this won't work. Did I do AA? Okay. So for example, if I just want to read in the first column, which is A, you have to do cell to cell. So you could do like A1 to A101. Or if you just leave the numbers off, it'll just do the entire column until the end of the data, which is what I just did. So this is just this first one. What you'll notice is that when I said XLS read communicates very well with MATLAB and Excel, they communicate really well with each other. You'll notice that there's 2 headers here, and it's just ignoring them because the algorithm is smart enough to be able to tell the difference between headers and data. So that's sort of new. It didn't used to do that. You used to have to get rid of the two headers in Excel. So that's how you read in one column. And then if you want to specify, some people have to do this on their computers, specify particular cells to go to. And then the other thing you can specify is the sheet number. And all of this syntax for the inputs can just be found in the help. So you can see here, first you put in the file name, then you put in the sheet name, then you put in the range name.
When you put in the range there, A1 to A whatever, did it include total, mid-year, and year? Because it only went to 2048.
That's because I added the 1 to 101 there.
So it goes all the way from...
So I skipped the last two.
Oh, okay.
But when I did this first, I just did A to A, so that did all of it. It auto finds the last one.
In this case, it ignores the headers again.
Yes. Wait. Did it ignore the headers when I did 1? Yeah, it does still ignore the headers because I did 1 to 101 and it's 99 big.
So it still just goes to 101 row, but forgets about the headers.
Yes, it didn't put the first two in here. Yeah. Again, this is not how it's always been, but it's pretty easy to tell because Excel is human readable, so you can always make sure that it's working pretty easily. But it does not use the headers to find the columns. So like with the spreadsheet you're going to be using, there's a header that has the name of the variable that you're going to read in, basically. So a lot of people want to just put that variable name in here because it's just easier, because some of the columns are like AC, you know, because it gets so long. But you do have to put in the actual letter column to read in that. But, so you can do either way, read in particular columns or the whole thing and then call out particular columns once you get it all in. For this assignment, it's much easier to call out particular columns because you can do the Control F within the spreadsheet, find whatever it is you're looking for. Is this case sensitive? That's weird. It works in the other one, but like, you know, search for the header that you're looking for and then find what column that is. Otherwise, you have to count the columns if you read them all in, and that's just a nightmare. So you'll just want to do that. Okay, but for now, what I'm going to do is I have my data variable that has everything. So I'm just going to create a couple variables just so I have them. So I'm going to save the first and the second columns. And if you just want to see what this data looks like, this is just population data, global population data. So it's just showing, whoa, that's also new.
Yeah, that wasn't in the...
Oh, no, it's not. What's that? I thought this was reading it as a date, but it's not. So this is what the data looks like. It's just the global population from 1950 to 2050 projected using population growth models. But let's say you have some variables. So I wanted to show you more about the native format. And this is what you basically have to do this if you want me to help you with your lab, because otherwise every time you run your code, you have to wait 30 seconds or a minute. And so you're going to have to figure out this algorithm to do binning, and you're going to write a little find algorithm to find the most likely habitable planets in the solar system using conditions roughly close to what they use to determine that. Because if you use the actual conditions, none of them were, and I didn't think that was really fun, so I just made them a little bit more liberal. Yeah, I was like, humans could live if it was like a couple degrees colder. But anyway, so so I want to show you how to speed this up. So the way you want to do it is you want to use the native format. So the native format is the .mat format, and it's very fast, even if you have a lot of data. So what you can do is you can save your entire workspace to a .mat file. And so again, the syntax is just you put the file name you would like to save it to. I chose global data. And then use the save function. So when I ran that code, I don't know if you noticed, but this file was created in the current folder, and that file just has everything in this workspace saved to it. So what you can do is clear out your workspace. All of those are gone now, and then go back and now load back in the .mat file, and you can see that it all comes back.
So in the end, we have to, I guess, put all the data in first and wait 30 seconds, but then save it.
Yeah, you want to figure out all the data you need, load it into MATLAB, save it to .mat files, and then just like comment out all that code that was reading in the Excel spreadsheet file. Or what actually a lot of students do is they create a separate M file that just reads in data, writes data, and that's just their data.m file that's used just for that purpose. And then they have a separate file that just starts by loading the data. And it's incredibly fast. And so you can do that, or you can just double click on it. That loads it in. I mean, you don't want to do that, but just so you know, if you're ever just like received a .mat file and you want to look at it, and then MATLAB now allows you to kind of look at the data by double clicking on some of the variables and stuff like that, which makes it a little bit more visual. The other important thing is that sometimes you have a lot in your workspace that you're kind of working with, and so you don't want all of it to go to your .mat file. You just created a couple variables. So when you do that save command, you can also just list particular variables. And the only thing that I find very weird is that you have to put those variables in string quotations, which is totally against everything we've learned about variables. Normally we just put them in as variables. And then if we clear it all out, and then we load it in, it only has those two variables there. It didn't save the entire workspace. Alternatively, you can save the entire, well, now it's all gone, so I can't get it back. But you can save everything to the .mat file, and then when you load in, here, I'll just show you with one of them. So let me clear out my workspace. You can just load in one or two. Also very important, because sometimes you don't want all of them. Because data, this is like the whole topic, data management, just like figuring out how to be efficient with all this data. Turns out to be a very important skill these days, is to be able to do this kind of stuff. Okay, you guys have any questions about that? Okay. Since you're going to be writing a binning algorithm in today's lab, I wanted to show you a little bit about these types of algorithms. They're more or less the only type of algorithm we write in this class. They're all very similar, but and I call them like find algorithms, but I like to kind of lay out the differences. So I'm going to do a different example. Which might not sound the same as what you're doing in the lab, but it is the same algorithm. So I'm not going to, so that we can kind of like process this, I'm not going to read in data for this, but just imagine that you could, and it would just be, you'd be able to have data with more precision, more data, and things like that. But let's just say that you had an array, variable name heights, or height, that held a bunch of heights in the unit of inches. And the goal of this code was to first bin the heights. So a binning algorithm basically puts the data in different categories. So for example,
Kind of like what we, or like on the practice test with the cars.
yes,
Okay.
it's like the cars. That one didn't bin them.
Oh, it just counted them. That's right.
I think I just had it counting them. Yeah.
But it's similar.
But counting is part of binning. So let's just pick the two bins, I guess. We'll just do a cutoff at 5 feet or 5 inches. No, 5 feet. And we just want to find how many are in each and which ones are in each, right? Which is two different things to do. And so it's also a little bit similar to what I had you guys do in Cody coursework, I guess. But you can do it two ways. You can do it in very few lines using some of those logical operations and indexing, or you can do it in loops. In this lab, I want you to write the binning algorithm in a loop because you don't actually have to. People have not written in loops, but I can't remember. It actually doesn't matter too much. But once you get the loop written, everything else is pretty much the same. So I want to put them in bins and count them. And I think in your lab you just have to count them. Okay.
In this case, you could use a while loop or for loop depending on what you kind of want to do. I mean, since you have to go through all the variables of H. That was a bad question.
Yeah, you could do it in a for loop or a while loop. Yeah, you can always do anything that's in a for loop in a while loop. But for a binning algorithm, you know exactly how many things you need to check. You need to check each one. Yeah, so you just want to use a for loop. So the first step is that you need the data. Once you have the data, our bins are in a different unit, and this is very important for your lab. There's a lot of unit conversions that you have to do for the lab, otherwise it doesn't work. And so same thing here. You need to either convert your data into feet or your conditions into inches. You can choose which one that you want to do. And then you just want to start by thinking about the first one. So for yours, and you have to write two different algorithms in your lab. One is a binning algorithm that just places it in different categories, and one's just a general find algorithm that's checking if a bunch of things are true, like if the planet has reasonable temperatures, if it's reasonably close to a sun, and those types of things. And so kind of in both, there's a bunch of conditions that you need to write. That just is going to be some relational condition. So you just want to think about the first one, and then you have to do something with it. So remember, you can create a condition and you can check for anything, but then you always need to do something with it. So in our case, we're going to place that data into a bin, meaning we're going to save the value or something associated with that to another array. and then we're going to advance the counter to count how many we've found. And then once you do that with one of them, which is step 3, you just repeat all of step 3 with all elements in the array. And the way you want to think about it for your lab is you're repeating it for all planets because you have a lot of data for each planet. So you kind of want to think about doing it for each row. And then once you have all of your bins and all of your counter, you want to do something with that to show the results. So that's either going to be printing it to the screen or making a plot. And so for your lab, you're going to create a histogram plot that shows the number that was found in each one, which uses the function bar. It's really easy to use. It's just type in bar and then you put in the numbers that you want it to plot. So let's go through and convert all of these things that we just went through into code. So you're going to have your data defined or read in. So for your lab, this step 1 is going to be all of the reading in, which is a huge portion of the lab. And then once you get the data in, you're going to need to convert a lot of different things, whether it be the conditions or the data. So we're going to just convert the original data. Why am I having such a hard time spelling height? So we're going to convert it into feet so our conditions match our data. All of the conversions that you need are either very obviously searchable, like how many miles are in kilometers or something like that, or I give it to you in the lab sheet because we are doing stuff with like space, so there's a bunch of weird units that you might not have ever heard before. And then once, then you need your condition. So the condition, if it's in a loop, will need to be indexed, or if it's in a logical indexing, which is more possible for one of the two cases than the other, then you don't need to index it. But let's just put in, I said greater than or equal to 5, and so that's going to be the condition, and then that will need to be contained within an if statement for the loop because I'm going to write it as a loop. Then you need to put it in a bin. So I'm going to show you how to do this, but there's this nice trick that I don't think we've covered yet in a lab, but it's really useful. I think I might have shown you it when you were reading code, where you initialize an array as an empty array outside of the loop, and then inside of the loop you basically add on to itself.
So you can't pre-allocate.
Right, you can't pre-allocate binning because you don't know how many are in each one.
So what if you have like millions of pieces of data? Wouldn't that cause...
Then you wouldn't use a loop. You would just use logical indexing, because with logical indexing it would just find them all and then you could just access it back into the original array if it was actually going to slow something down. But it's still kind of a this idea of not knowing how many something is going to be sometimes is unavoidable, you know, and you can't pre-allocate. And so this is the way that you do it. Initialize it empty and then fill itself. So that's how you would fill in the bin. And then we've already done counters. So with counting, you just initialize to 1 and then advance the counter. For this, we're repeating a set number of times, so we're just going to use a for loop. And then for this one, I'm just going to display it, but for yours, you can use both plots and bar graphs to show your results. So let me just put that all together in a script file really quick so you can see how it all works. So I'm going to start by getting some data in here to use. So this will be your read-in command. Oops, sorry. And then I'm going to do the conversion. That's weird that I called that height in. Yeah, I'll change it. But it's not going to match up with what I just wrote. Okay, so what we're going to do is now structure the code. So we kind of know it's a for loop and an if statement, and so now you need to kind of piece it all together. So I'm going to start by doing the for loop first, and then the if statement second. I know right now I already know what the for loop needs to do. It needs to run for all of the elements in the converted array. So we'll set that up too. Right now, I'm just going to start with the first bin, which is the greater than 5 feet bin. And remember that because we're doing this in a loop, we're checking each element individually. So we need to index this, and then we're doing it piece by piece. We're going to do two things in here. The first thing we're going to do is save the ones that met this condition into a new variable that I've called height 5. Again, not a great name. And then I'll just initialize that bin to empty. Every time this condition is met, it's going to take that array, add on the next element, and now the new array will have that element in it. And I'll even unsuppress this so you can see it build within the loop. And then I'm going to create a counter that counts how many times this was true and initialize that counter to 0. What I'll do is just unsuppress both within the code, within the loop, so we can just see it. And I will run it.
Wouldn't it need to be I, or no, not I plus 1, that one. That only brings it to 1 every time.
For what one?
If C5 is equal to I plus 1, but I guess it doesn't.
Yeah, so with a counter, it always has to be self-referencing because it keeps updating the same variable. So when I printed this out,
Oh, yeah, I see it now. I was thinking of a while loop.
yeah, so what we do with while loops is the same thing. It's a counter, but we're using whatever the index of the loop is as our counter advancer. So it looks like the only ones greater than 5 feet are 60 and 75. There's only 2. So it first found 60, which is 5 feet, and it added 1 to the counter. And then it found 75, which is 6.25 feet, and then it added 1 to the counter. And so if we had more in here, then it would add more to the counter and fill up the bin more. And so that just is one bin. So I'm just creating one bin. But then if you wanted a second bin, or in your case, I think you have to do 5 bins for your lab. And again, this is an unnecessary condition in here, right? Because it's the whole thing with the else's. Everything in this condition, everything that's not in this condition is already in this condition, so I could just leave this condition off. But I find that it's more, sometimes it's more comforting for people to know that they like have maintained every one of them. So what you could do is create, like, don't have a variable name to use for this because I use such a weird one. So I'll create the other bin, and I'll just start at the bottom of the bin, which would be 0. And I'm just going to do the same thing, but I have a new bin and I have a new counter. So now this should always equal, count 0 plus count 5 should always equal the length of height, right? So let's just now let's just unsuppress these, and let's just print them at the end because it's a little bit confusing now to look at them all at the same time. So there's 4 of each, and there's 8 elements, so it's placing them all in each. And yeah, and so if you would like to create a bar graph of this, the way you do that is a bar graph basically reads in an array of numbers, and then it just plots bars for each of those numbers relative to the other numbers. So let me just show you it with random numbers. So I just put in 150, 60, and 70. You have to put it in a square bracket because the bar function reads in an array. And then it just plots each one. Do you see that? And so what you guys want to do is the same thing, but each one of these is going to be one of your counters from your binning. And you'll have more than that, and it'll look something like that. What I like to do when I'm writing binning algorithms is I don't like lots of variable names, and so instead of having to initialize 5 variable counters, like count 1, count 2, count 3, I just like to initialize an array. So I would just do, like, I can use count because I haven't used it yet, like an array that has 5 zeros in it. And then I'll comment this out so it's not actually doing it. For this bin, I would just advance 1 element of the array. So you're like counting, your counter is also an array. Does that make sense? And so then when you do the bar, you can just put in count instead of tying all those together. In general, it's just good practice. Instead of, if you have a lot of things that mean the same thing but are for different things, like counters, it's a good habit to just put them all in an array and then access that array so that you're not having to come up with 1,000 different variable names. I do that with arrays too. So if I have a bunch of arrays that have the same purpose, you just put them all in different columns or different rows. And that's pretty much it. I think, do you guys have any questions? Okay.